Hello again, chemistry students. This is Mr. McKee, and we already went over how to measure mass for our density lab. So now I want to talk to you about how to measure volume. This is a little bit trickier because we don't have a digital tool like our balances to do this, so we have to do it the old school way. So this is part 2 of the experiment. So the first thing I want to talk about is how to use the graduated cylinder. This is a graduated cylinder, a little picture of one anyway. And you'll notice that there is a curvature here, and that's because the water molecules are actually attracted to the side of the graduated cylinder. So the question is, where do we look for the line? And the answer is we're going to look at the bottom of the curvature, which is called a meniscus. And if we look at the bottom of the meniscus here, we see that it falls on the 21, 2, 3, 4, 24 milliliters. So that would be our measurement. You'll notice that the top actually falls more close to 25, but 24 is the measurement that we want to use. So that's a basic reminder about how to use the graduated cylinders. Now, how are we going to use the cylinder to measure the volume? We're going to use a technique called displacement. And it's based on the fact that when you put an object in water, if the object is fully submerged, that means underwater, then the water is going to be displaced or moved up by that object. And the amount that it is displaced is going to be exactly equal to the volume of the object. So for instance, in this diagram, we have the initial level of the water, which is 17.1, and that's right here. Initial means at the start. And we have the final level of the water, which is at 19.8 milliliters. And the difference in those is going to be 2.7 milliliters. So that's how much the water went up after we added this chunk of gold here. So that means that the volume of the gold is 2.7 milliliters exactly. So this is the same technique you're going to use to measure the volume of the pieces of metal that you are trying to identify in the density lab. Here is another diagram that shows basically the same thing. Here's your piece of metal right there. And we see that the before volume was 61.5, the after was 81.5. That means that the overall volume is 20.0 milliliters. Okay? So that's how we're determining the volume. Now let's talk about how to record this data. So data table 2 in your booklets is for volume. And the thing I want to stress is that each person in your group is going to fill out this table independently of the other people. So this table is just for me. All right. The example shows how we do this. We're going to use our graduated cylinder, as I just explained, to first measure the initial volume, that's the starting volume, and then the final volume, and then we're going to subtract to get the difference between those, and that's going to tell us the volume of the metal sample. So I just figured out here that my example metal had a volume of 9.5 milliliters. Always make sure to put your units there. So you're going to do that with metal piece A, B, C, D, and E. And you can put your name up here, your box number. Remember my box number was metal piece 7. And each person in the group is going to do that. Then, after each person has filled out that table, you're each going to input your data from table 2 into table 3. So I would put all of my volumes that I just calculated in here, and they should be pretty similar to the other people's volumes if we have done it correctly. Again, if you have one piece of data that kind of sticks out, here's Damien again. His is quite a bit different than the rest of us. So you would want to redo that, talk through it with Damien, and make sure that he did things correctly and that the rest of you did things correctly. When you're all done, you're going to have a whole bunch of data here for the 5 pieces of metal, and you're going to calculate the average volume for each. That's the main objective that we want for table 3. And that is how we determine volume and record our data.